Hey everybody, this is Jason from the Children's Museum of Houston, and this time for the A-STEAM projects we're going to talk about geology. Now geology is something I really truly love. I really love our natural world, things like astronomy and biology, and geology is as much a part of our natural world as anything living. And that's sort of where you need to go with this. Geology is the study of minerals, it's the study of rocks, but it's also the study of how our planet looks and how it changes, how other planets look and how they change, the landforms of other planets and our own. Really anything to do with sort of like the stuff above the planet, or even below the water when you talk about the crust of a planet if it has a lot of water. So it's the makeup of a planet. It's the crusty, rocky parts of a planet, or a moon even, or a dwarf planet, any of that stuff. But what you really want to get across to your students is geology really focuses on minerals, rocks, which are made from minerals, and landforms. It also focuses highly on how rocks are created. There are three types of rocks. Many of you have probably heard of the rock cycle. Igneous rocks turning into sedimentary rocks. Sedimentary rocks turning into metamorphic rocks. Metamorphic rocks turning back into sedimentary rocks. Sedimentary rocks turning back into metamorphic rocks. Metamorphic rocks melting and becoming igneous rocks. Sedimentary rocks melting and becoming igneous rocks. Igneous rocks becoming sedimentary or metamorphic rocks. That's why it's a cycle. You can go either way. Any rock can beget any other type of rock. What we're trying to focus on this activity, though, is something that the kids don't often get to see. Lots of people do the crayon rock cycle or the candy rock cycles or the Play-Doh rock cycles, but a lot of times what we don't see are the actual forces that create the rocks. So what we have set up here for you is a way to demonstrate how these different rock types are made. Not only will we show how the rock types are made, we'll also show you different rock types from each of the rock types. So 3 different igneous rocks, 3 different sedimentary rocks, and 3 different metamorphic rocks. That way they can see how diverse igneous rocks are within their type, how diverse sedimentary rocks are within their type, and how diverse metamorphic rocks are within their type, but also certain similarities they might have to one another. So let's go ahead and start with igneous. Igneous rocks are made through the forces of volcanism, volcanoes. Now, one of the biggest misconceptions about igneous rocks is that they're only made when lava flows out of a volcano and that lava dries. That's not true. Igneous rocks can also be made inside a volcano and get blown out. Igneous rocks made inside the volcano are called intrusive. Igneous rocks made outside the volcano are called extrusive. There's one other little difference you need to know about that. Inside the rock, lava is called magma, or inside the volcano, lava is called magma. Outside the volcano, magma becomes lava. So outside, lava, inside, magma. So both magma and lava can make an igneous rock. So what you want to do here with your students is, it's very experiential in this one, but a lot of fun. You're going to let them erupt a volcano so they can see a volcano erupting and sort of look inside and see how it bubbles first on the inside, then it starts to come out on the outside. And you even get to see it kind of dry around the outside of the volcano, forming what we can consider rocks. So really simple, you just take some baking soda and you pour it inside the caldera. And then this red stuff is actually vinegar. We dye it red though, so it looks a little bit more like lava. And you just start to squeeze it in. And then it starts to come on out. A big erupting volcano. Now, obviously, your students are going to want to do this more than once. What I suggest with these different activities is you break your kids up into groups of 3. So if you have 10 kids, 3 kids can start with the igneous, 3 kids can start here with the sedimentary, and 4 kids can start with the metamorphic, and you rotate them around. So sort of set these up in different areas. When the kids are at the igneous station, let all 3, 4, 5, whatever, all erupt the volcano once, because they're all going to want to do it. Now, As this lava starts to dry, or as this vinegar starts to dry, you're going to start to notice that a little bit of the baking soda is going to sort of dry with it, and that would sort of indicate the formation of rocks. Interestingly enough, there's more than one type of lava as well. There's actually 3 types of lava. There is a type called Pahoehoe, there's a type called A'a, and there's a type called Pillow. Pillow lava is the most common type because it's what created the crust of our Earth. Everything underneath the ocean, all that, was created by Pillow. Then you have sort of Pahoehoe, and you have the A'a. A'a kind of gets its name in a joking way, even though it is a Hawaiian word. It's a little bit more crusty of a type of volcano. So like if you were to step on it, it would feel like you're stepping on Legos, the most painful thing in the world. So it's like, my feet. Pahoehoe is more of a smooth lava. It's kind of like the lava you see coming out of Kilauea. Have you ever seen videos of Kilauea? That's sort of always kind of dripping out is the Pahoehoe lava. Now, all the different types of lava can technically make all the different types of igneous rocks, but in cases you sort of see like Pahoehoe might make this type of rock more, which is an obsidian igneous rock. Obsidian is known because it's very glassy. It's also very hard, but it can be quite brittle, and it's very smooth. Your Pillow will make this. This is called basalt. This is the most common type of rock on our planet Earth because it makes up the entire crust of our Earth. So basalt's very, very common. This one right here, this is called pumice, and it's actually typically made inside the volcano. This is typically an extrusive rock, but it gets blown out when there's a very violent explosion. What's cool about pumice is that we use it. We use it to scrub our feet, get off the dead skin, all kinds of stuff like that. We also are known to let this rock float on top of water. It won't sink, it floats. So it's kind of a fun thing to do with the kids. When you look at these 3 rocks though, you can see that they're totally different, but they're all made from the same sort of force, this volcanic force, which is very interesting. And this is only 3 types. There's dozens and dozens more. But when you're doing your volcano, that's what you kind of want to focus on. We give you little cards for these so that the kids can know like which one's obsidian, which one's basalt, which one's pumice, and there's like a little bit of a sort of fun fact for each one. Let's turn our attention now to sedimentary. Sedimentary rocks form a lot differently. First of all, there is usually a bit of erosion that occurs around a place that already has rocky surfaces. Erosion can occur 3 different ways. There's wind erosion, where wind just kind of blows off little parts of a rock, like little sand bits or whatever. There's ice erosion, which is typically made from a glacier, which is a moving piece of ice, slowly moving piece of ice, like an ice wall or ice shelf. And then the most common, which is water. That's why when you look at plants outside of our Earth, a lot of times you don't see erosion on rocky plants because there's a lack of water. And water erodes things much more quickly. When I say much more quickly, we're talking millions of years faster as opposed to billions of years. So it's kind of relative when you think of it that way. But usually there's a bit of erosion. And what happens is if the water especially erodes something, it'll move that eroded material and deposit it somewhere. So what we have here is a very small mini stream table or an erosion slide. And this very small mini stream table is very effective in showing erosion occurring and deposition occurring. So you just have yourself a cup of water and you pour it into this little rainmaker. It takes a minute at first, but it'll eventually come out. And you can see it's trying to move all that material out of the way. So it's eroding it and it's depositing it down over here. It's just pretty cool. But one thing that kind of happens here with kids is if you only have one colored sand, they don't really get the idea that it's not only eroding something and depositing it, it's also sort of layering things on top of one another. So you get these layers, and as they increase in size, the bottom layer, there's a lot more pressure. And that's what's actually causing a lot of sedimentary rocks to form, is that compaction that occurs. So one thing you want to do with this one is we also have different colors of sand. So after you do that, you add some orange sand, and then go ahead and erode that. So pour some more water inside. And you start to see that the orange is now coming out and it's layering on top of the brown. We also have some blue sand. So we're going to put some blue on top. And we're going to pour some more water in. And you'll start to see that the blue is now moving and layering on top. So this one's really good at showing how the erosion moves it, deposits it, and layers it. And eventually, if we had a couple hundred or a couple 100,000 years, we could see how the rock is formed. So we have a couple of different rocks here that are sedimentary rocks. This one right here is called a conglomerate. This one really shows the compaction that occurs because you see these really big bits of rock that have sort of been cemented together. So obviously lots of different rocks were eroded, deposited somewhere, and put together. Then we have a sandstone, and you can see the layers of this one. You can see how it layered, how it compacted in these layers to form this rock. You find a lot of sandstone in the desert areas of, say, like Arizona, Nevada, Utah, New Mexico. Then we have the most common of all sedimentary rocks. This is shale. And if you look really closely on the side here, you can see the layering here. Now, lots of geologists are interested in shale because a lot of geologists work for the oil companies, and shale deposits is where you find avenues towards fracking. So geologists work in a lot of different ways, and they do a lot of different things, and sometimes they do things for companies that allow us to have energy or allow us to find new forms of energy. And that's where the shale becomes very important because it's something that geologists are hired very much to go find to help out these oil companies. So that right there is your sedimentary rock one. The last one is one where the kids can take home. This is the metamorphic rock. So we have these different Play-Dohs, and you just give them a very small amount. And you make a little ball. All right, so you got a ball of red, and then we'll make a little ball of blue. Now metamorphic, that word metamorphic is the same almost as metamorphosis. It means a very, very sudden change. There's a high amount of intense heat and a high amount of intense pressure. And when that happens, a sedimentary or an igneous rock will change. A lot of times when this happens, you start to see these little layering lines, and very common in them. And there's one rock here I'll show you in a moment that you can really see those layered lines. So what you're going to do is you're going to take these and you're going to put them in your hand and you're going to smush them together. You want to use a lot of pressure, use your strength. And it actually, your hands will start to get warm, so you'll get a little bit of that intense heat going on. And you start to see that there's a little bit of a kind of mixture between the two rocks. We'll get a third rock in here. We'll get a purple one. And then we'll mix this one up again. And then we'll push it together again. And you start to see, you get all the different rocks together. And we'll get a little piece of yellow here. And we'll mix it up again. And then we'll mix this one up again. And we'll put it all together. And then you start to see you get another change. And you can see like the red starts to come over in the blue, and the purple starts to blend into the red, and the yellow and the blue. And then you can sort of just smoosh it around in all different directions. And you start to get a rock that looks very much like what we call gneiss. You look at this one, and you look at this one, you can see that they look very similar in the way they're kind of lined and everything like that. Gneiss is a very, very common metamorphic rock. It's known for its crystallization. If you look really carefully, you can see the crystals on this rock, and it's known for having these lines with it as well. But there's other types too. We have one that's really interesting. This is slate. And slate is shale that is hit with intense heat and pressure. But you can start to see that the layering becomes more and more fine-grained right here. And then we actually have one, this is a graphite. This is what you find inside your pencil, okay? So you kind of can draw with this one. If you really look carefully, you can sort of see that I can make a little bit of a mark on there. It's kind of, because the brown, it's kind of hard to see, but if you have white paper, you can make a mark, and it's really pretty cool for kids to see that. So these are how all these different rocks are made, but the cycle can go in either direction. It doesn't have to go from igneous to sedimentary to metamorphic. You know, their metamorphic rocks can turn immediately into igneous rocks, or metamorphic rocks can be eroded and turn into sedimentary rocks in all the different ways as well. So you can look, you can kind of see like there's this like kind of crust forming here by the volcano, like I said earlier, that kind of show the rocks as well. So this is the way in which the three different rock types are formed. Like I said, with this one, with your students, you might want to put them in the groups of however. If you have, 25 kids, you're going to have to put them in the larger groups of, 8, 9, or whatever it has to be. But this is a very, very cool activity for the kids to actually learn not just the rock cycle, but how the rocks are actually made. And on this one, the Play-Doh one, they can take it home with them. They can show their parents like, hey, look, I made a metamorphic rock using something as simple as Play-Doh. All right. That's it for this one. Hope you enjoyed it. Hope you learned some things here, and we'll see you in the next one. Thanks a lot, guys. Bye.